Hey guys, so I'm just gonna have a quick video here of kind of, I don't know what you want to call it. It's just some different type of effects you can do with these motors with putting coils in series with one another. This is just one extra coil in series. It's right here. So it's in series with these ones. Well, there's really 4 coils in series, but I just call this one, and that's one. And I have them hooked up in series right here. The wires go across there. Just a normal driver circuit, collecting the back EMF, flyback normally. Got the scope here, positive, negative of the driver coils. That's where it's hooked up. Just a 13.1 volt battery. So what it's at there, 13.1. Here's the scope for the current probe. It's right here, set on 1 millivolt. 10 milliamp setting. Center one. It's zeroed out. Zeroed out even more. Everything's calibrated. Channel 2 is the reading right here. Frequency will be on that one there with the voltage in the center. And it's just reading the AC off of that bridge rectifier from this coil right here. So I'll start it up. And then once I get it running, I'll show it running. Show you the current draw. And then I'll end up tuning it by moving this coil over, retarding it. And I'll explain a bit more, and then I'll show it through the LEDs that there's power going both ways and on the scope. So there's the flyback and the lights there like normal. Starting up, here's the so this area here is a center line where it's 0. Anything below that is current going into the motor. Anything above it is current going back into the battery from the motor. And you can see it rising above that center line there now. I'll pause it to get a better view of what's actually going on. This is the signal going into the motor, voltage. This is the current. This way though I have it inverted. So the bottom part is going into the motor. This is going back from the motor to the battery. And that's the current right now, which is pretty far off. Like, these gauges aren't very accurate to what's actually going on. This shows you right here, VB 54 millivolts. So that's 540 milliamps to the bottom right there. Right, so I'm going to just adjust the coil. And there's the frequency, 221 hertz. So when I do this, the power level is going to drop. You can see I can even make it go negative. And put it back right there. And the motor's slowing down, but the current has also dropped. Flyback is still there, it's not as strong. So about 50 milliamps there. And you can see quite a bit of it's getting returned back to the battery. So not, yeah, this too, I forgot to say, is the center line is up here where the 2 is. Anything below that is the flyback. And this is the signal going in right up here. This is the power, the flyback. We'll just go into the light. And some of that makes it back into the battery. That's what you're seeing up here. And these little round humps here. That's power going back to the battery. This is current going into the motor. This is the flyback. Well, this is the flyback spike right here. This part right here is the magnets passing the coils, which acts like a generator, alternator, I should say, when the motor's off for 50% of the time in this off period right here. That's it right there. So it induces enough of a voltage to be able to send power back into the battery. Let me turn this back on here. Oops. And then the red LED is power coming out of the battery, and the blue one, well, they're the same LEDs. I've just got a marker on them, red marker and blue marker. So I'll take it off of here, put it on here, and you can see they're both really bright. And here's the scope shot when it's resisting the power through the LEDs. But that top one wouldn't be lit if there wasn't any power going back. Let's see if I can adjust the coil to where it doesn't want to go back. I'll end up blowing the LEDs if I do it wrong. Let me just put it back on here. I'll do this real quickly. I'll just put it back to a parallel connection, and all I have to do is move this wire over. The wire can do it while it's running. Try to do it one-handed. When I put it here, it's going to be just on one coil. So it uses a lot more current right now because they're not in series anymore, but I'll turn it down. And this motor is insanely powerful. It has an insane amount of power. For the amount of energy it uses, it's nuts. You can see. You don't want to try to stop that one with your hand. But you can see now there's no more power going back into the battery. So let me turn the current down here enough so I can put the LED on it. Where as it's slowing down, it puts power back into the battery because it has momentum. Let me see, as I slowed it down, it stopped putting power into the battery. That was just the momentum of the rotor able to push power back into the battery, kind of like regenerative braking type of thing. So now, I didn't hook the scope back up. And it hit some weird frequencies where it does this stuff. Watch what it's doing there now. Until the rotor balances itself out. And then everything smoothens out again. You can see there's nothing going back into the battery. So I'm at a point here now where I can take it and put it through the LEDs because it won't blow up the LEDs. Actually, I think I blew that red one when I adjusted the coil. Yeah, I did. But you can see only the red one's trying to turn on. And the blue one isn't on anymore. But that red LED is blowing like it's not working the way it should be. It should be really bright. But it's still letting power through. It's shorted out yet, that light. But the blue one's not turning on. The blue one would still be fine. Yeah, it's totally... She's dead. Let me just go see if I got another set of LEDs. I'll be right back. Yeah, I had some, so I just put them on here. There's the ones that are no more good. Just put this back on. I'll let the motor gain speed again though first. It's doing its thing there again with the frequencies. I'll just wait for the current to drop a bit more. See, there's nothing going back into the battery. It's got a PWM signal here now because I turned it down. See, it's pulsing it. It should be good. See, you can see how bright that light is. It's doing its thing there with the frequencies. But there's no blue one on. No power going back in. I mean, I fried that LED too. It's just too much current. It's got to be around the 50 milliamp setting before it won't wreck these LEDs. I'll just flip it around to the blue side and show you that light actually turns on too. Probably blow it too, but you'll see it turn on. See? That's the blue one. It does work. When power flows back into the battery, it turns on normally. So I just wanted to share that anyways. And another thing too, probably end up showing. I've never done it with any of these small motors yet, and I haven't even done this with this setup. I haven't put any of the coils in series like this with this setup. This is the first time I've done it in years since I've had my big motors. But what you can do with this is offset the motor to be able to backfeed into the battery with one of the set of coils that are in series. You have to have... What works best is to have... Like it all depends though. It's like if you have 5 and 2 coils, like 2 coils feeding back into the battery and 5 of them that are actually like 5 coils in total. You know, so you have 2 coils that are feeding back into the battery, offset, like retarded timing, and 3 of the coils that are driving the motor normally in like and properly timed and tuned to where they're not retarded, because the timing is really important with this effect. And the position of the coil, like having coils like at a, I don't know, equally spaced and equal to the rotor is not what you want. You can see how that one's offset, this one's offset, to get that effect. Like, this is the way it is when it's timed properly. It's pretty much right where it needs to be, right there, where the coils are working together. But you want to have them like this one retarded, and the more you retard it, the more you'll have of power going back into the battery, because you're still inducing the current through that coil, but you're able to send it back to the battery when you do that, because it's out of time. Like, that one's not being used right now, it's just this one that's driving it. But it's really interesting, and when different motors do different things. So I just wanted to show that. There'd be more of this stuff coming up. I've been really busy at work, so try to get you guys a video every week, but it's kind of tough right now. So, any questions, don't be afraid to ask. Anyway, thanks for watching, guys.